Thank you, Odika. So as she said, I'm Kevin Jones. I'm from Red Hat. I'm specifically in the U.S. public sector division of Red Hat. So we set out to solve a problem that our solution architects had, actually. When we go on site to customers, we don't typically get network access, which means it's really difficult to show our software portfolio when we have no capability to reach it. That means we need to bring it with us. So we had several requirements. It needed to be less than 50 pounds, fit in a rollerboard case so we could put it on an airplane. It needs to plug into a regular outlet in the wall, power it on, and have internet access broadcasted by Wi-Fi so that customers could get right on and touch our software. So when we did this, what we found interesting, and this is the little kit that we've come up with on stage, we found that this brings up a whole different conversation. It makes the software tangible in a way that normally, give me just a second. There we go. In a way that normally doesn't happen when you're just showing the software remotely. So we've started to discover all these different use cases that we weren't really aware of. There's a few we were conscious of in the marketplace, but a lot of these are coming out of the woodworks. So these are a couple example field kits that exist today. The one in the lower corner there that says DLT, we're actually working with DLT to build this and be able to sell this. So you order a single SKU, DLT assembles this kit, lays down the software, drop ships it to your location. But the commonalities in here is you need a small footprint, portability. Some use cases require ruggedization. So the idea of a small amount of sand infiltration or heat is a big example there. The other thing is we're seeing is the need for not only a compute-based cluster like that, but maybe a storage dense cube that could be delivered, or an analytics cube that has GPUs in the box. The most commonality between all of the use cases is low power requirements, and the same bits that run on the field kit are the ones that run in the data center. So they need to know that the applications that they have built and tested and validated are going to run when they're sent out into the field. So I'm going to talk through a couple of the use cases that we've come across. The first one is disaster response and recovery. And we're all at an IT conference, but this is not DR in the data center. This is disaster response in real life. So the idea of a hurricane or a tsunami, a tornado, these agencies and organizations have to send people out into conditions they don't know what the situation is. They may not have any network connectivity. They may need to bring their own network broadcast capabilities. They might have unstable power at best, if they have power at all. And then in total, you're aggregating multiple organizations. It's not a single organization. You have to put applications up that handle logistics and communications for these different organizations. So if they had more portable infrastructure and they can run the same software that they run in the data center on these edge kits, then they will know that when they get there, they will have the applications and communications that they need. The next use case is one we have known for a while, and there are many field kits out there for this use case, but they're typically very large field kits. This is the one that needs the ruggedization most, and these are military operations. So the idea of sending a kit out to a remote location, it needs to survive transport. It's going into probably a hostile environment, and the thing is, the responsibility of these systems are actually human lives. So both the servicemen and women that are out there handling the operations, but also the civilians that are in the area and are there to be protected. So the kicker here is that if you need ruggedization, you will typically sacrifice on portability, and the ones that need portability will sacrifice on ruggedization. So they're typically an either-or situation. The next one I'm going to talk about is cybersecurity. So this one is really interesting. I actually kind of fell into this one. I went out to San Antonio. We had a public reference last year from a systems integrator called Radiance Technology. And we went out to the 90th Cyberspace Operations Squadron, which is responsible for developing the cyber toolkits that are being used out in the field. And they wanted an agile platform, and they chose OpenStack for that platform. Now what happens is they develop these tools, they ship them out, test it at another location, and then they ship them to another location to train operators, And ultimately, they send an operator out with a field kit, and he has to be confident that those tools will run the same way they did when he got trained in the data center. And so the idea here is to give the operator a kit that they can roll just like I did. It never leaves their side, and when they get there, they can plug it into the compromised network, and they can actually consider this little kit disposable now because it is compromised as well. So that is a really, really interesting use case that we have been working on, and it's significantly important because we need the good guys to win this war. The last one is near and dear to my heart. So this is the idea of sending commodity Earth-built hardware up into space. So this is actually being tested right now. There are x86 platforms up in space right now on the space station, seeing how they handle zero gravity, how they handle the harsh conditions. You have to think about that you have very, very tight places you have to put these into. And at the end of the day, they can be lives of astronauts that are dependent on these systems as well. The other piece that we're working on right now as a world is getting to Mars. So what's going to happen is if we send this hardware, Earth-based hardware, up into space, it functions well. We're going to then validate the software that we've been running on Earth here in space, and then we will ship that ahead of the exploration to Mars. So the idea is that the habitats and the systems that are going to run there will be shipped before anybody else is, and they will be up and running and capable of being used before the human lives arrive. The kicker here is that there's a latency, so the response round trip from Mars is 14 minutes. So when Curiosity landed, it was actually 14 minutes before we on Earth knew that it had landed safely and was already rolling on the surface of Mars. So that's an important use case. There is one that I forgot about. This is actually a Red Hat use case as well. So there are many people that send out on-location training. The way Red Hat does this today is we ship 1 to 4 Pelican cases full of laptops. Those laptops are obsolete almost the day we buy them. They're always under-resourced. The instructor has to arrive probably 2 days in advance because they want to get there so they know that if they have any hardware issues to deal with in those laptops, they don't know what the state of them are from the last one they were at. They have to re-image the systems. These are isolated networks, so when we do our certification and exams, when the student environment, they're not allowed to have internet access. So everything has to be in the environment in the classroom. And the other thing is the student experience is not great because at this day and age, to run what I have on that kit in a laptop, you'd have to have a minimum of 64 gigabytes of RAM, and you wouldn't even be running the applications on top, you'd just be running the infrastructure. So it'd be way nicer if the instructor could just roll this kit into the room, plug it into the wall, power it on, it broadcasts a network in there, the students bring their own devices, connect to the network. He kicks off a playbook when he starts the class and creates however many student environments there are. OpenStack happens to handle multi-tenancy very, very well by default. So this is a great, great use case for us even internally. The last thing I want to talk about is one I was working on 2 weeks ago. So I was sitting there trying to figure out what I was going to present at for this. I have a session tomorrow at 3:30 talking in more detail about some of these use cases. And sitting there working with my friends Ken Holden and Laurent Dome there, and one that's not pictured named Joe Ankoviak. But Red Hat intends to drive this truck around the US, continental US and parts of Canada for the next year. And so the truck has to have WAN connectivity when it has cell access to towers. So we had to build a whole network for this truck, and then we had to have enough infrastructure for the 40 students that can be housed in that trailer. So we want to do demonstrations, customer site visits, conferences, and that kit, the picture of that kit is the one sitting here, obviously, but there are 3 of those in this truck now, and we have created push-button deployment for that. So you actually plug the kit into a Pixie network, it Pixie boots the build node, and from there, Ansible deploys everything else. It takes about 3 hours to have full Red Hat Cloud Suite plus the applications running on top. So it's a pretty awesome use case, and I was sitting there thinking, hey, I'm building one actually right now when I haven't even prepped my presentation for next week yet. So Anyway, this is the reason I came in. Jonathan saw my presentation for tomorrow and asked that I come out and talk because there are many, many other use cases beyond the telco use case that we all know and love today. So I just wanted to share a few that we've stumbled into. So thank you very much.